morning, one and all. The subject name is compiler design. In this subject, we are going to give a brief overview and some of the problems which are related to code optimization and code generation phase. Code optimization phase and code generation phase. Previously, we have computed with examples like code motion, copy propagation, and common sub-expression elimination. Like that, some of the examples which we consider. Now, we are going to see that another example that is related to induction variable elimination. That means here, we are going to eliminate some variables from the loop inside. Why? Because there will be several number of variables, 2 or more induction variables inside the loop, and this is where it is could not get rid of all those things. So we have to eliminate it. So in order to do that, we have taken an example. In this example, a loop is to be described, that is loop block 3. Inner loop around block 3 in figure cannot get rid of T4 completely. Since T4 is used in B3 and J is in B4. For the inner loop around B3, the T4 and so here branch 3, what is that? J equal to J minus 1, T4, 4 is 4 star J. See here T4 in case of inside the block, that is inner block, that is B3, branch B3, block, in this block some lines of code exist. One is J equal to J minus 1, other one is T4 equal to 4 star J, T5 equal to A of T4. If T5 greater than V, go to B3. If T5 greater than V, go to B3. Now, in this, the T4 is computed is 4 star J. Now, instead of writing this 4 star J, so here the computation is strength reduction is to be applied. So we are going to, here J will be eliminated when the outer loop of B2, B5 is considered. So we are going to eliminate J. So B3 to B2 to B5, J is to be, we are going to eliminate. So here J equal to J minus 1 has to be written. T4 minus T4, T5 equal to A of T4 if T5 greater than, go to B3. So only the part here, this one is also same as this if I greater than equal to 0. Now here in this case, block B1, the statement is to be kept as is, J also kept, T1 equal to V equal to. Only the difference here is block B3, which is to be assigned, that is T4 equal to 4 star J. Now what is J? J equal to J minus 1. 4 star J. 4 star J minus 4. What is 4 star J? T4. So T4 minus 4. So T4 equal to T4 minus 4. So that is to be kept as a statement. So this 4 star J is to be computed instead of computation 4 star J several times. So here 4 star J means this is to be statement is to be kept outside, and outside means out of the loop, out of this block. This is the inner loop. This is inner block. This is the loop. This statement is to be repeated. This block of statements are repeated several times, and this is one more loop. So this is the inner loop. Inside inner loop, inside block B3. In block B3, inside loop, inner loop. This is. So in this inner loop, 4 star J several times are to be computed. So this star is to be computed several times. Instead of that, we can make out of this inner loop. Instead of out of this block, that means here we are going to put as a before this computation, before this block, before this outer loop. outer loop also, outside of this outer loop, we kept the statement T4 equal to 4 star j, so that the star computation, that means star is a multiplication operation. So it is an expensive operation for computing several times. Several times means inner loop can be executed repeatedly until condition. So that's why the star is an expensive operation. Instead of performing that many computations, simply we are keeping outside, and the result is to be verified in this T4. So where the T4? So here anyhow we are going to perform J minus 1. So that 4 star J previously we have computed, no, that is to be taken as T4, and the T4 is to be used as a subtraction J minus 1 and T4 minus 4, so that we can get rid of the problems inside the inner loop. So this is the one of the computation which is to be used for the elimination, that is B3 and B4. That is elimination of statement inside the block B3. Now another example which is specified about the strength reduction is, in this example we are going to perform x power 2. This is one of the computation. So in this computation is that means it comes under the term that is called strength reduction. Say strength reduction means instead of replace the expensive by a cheaper one. So that is called as strength reduction. That means plus, minus, star, slash, whichever is having lower this combination preference, that is to be as much as to be. So here power is a strong operation compared to this is a combination which contains power x power 2. Now whereas instead of that we can write x star x. So this is a multiplication company. Here it contains multiplication. So why not? Why cannot? Is there any possibility to substitute that expensive by a smaller one? Then you can use it without changing the result of that same computation. So in this case, I may go for a star operation, that is x star x, which is to get the same result as to this one for x power 2. So like this, any division operation. So here floating point division, now fixed point of multiplication or division with the power of 2 is very cheaper to implement than a shift operations. Another one is floating point division by constant, can be implemented as multiplication by a constant, and then whichever is cheaper we can check out and we can use it. So like that, out of this performing the operation shift, right shift, left shift, like that, any operations which are performing this one gives the same result, even though replacement of this computation, then definitely we are going to reduce that computation, strong computation with a less computation, so that we are going to get a reduction strength. So this is the operation which is to be used. Another important in case of algebraic transformations, the examples are, so here this is one example, another example is this one. So here in this example also, this comes under algebraic transformations. So these transformations can be applied same as that strength reduction point of view. First here the addition operation is to be used, which is same as the operations that is to be performed with the other remaining operations also. So the result is x, here also result x, result x, result x. But here the result, in all the cases result is x, but here it is performed an addition operation, here it is performed subtraction operation, here it is performed multiplication operation, here division operation. So which one is easier? Compared to division, multiplication is easier. Compared to multiplication, subtraction is easier. Compared to subtraction, addition is easier. So the levels of this operation are higher when you go down and slower when go up. So that's why this is to be used as a simple process with the additional as much as that one. So use that, apply this arithmetic operator identities and get rid of this higher level of operations. And another one is also which is related to example specifies algebraic transformations only. That is here also we are going to use a power operation x power 2 uh, and multiplication instead of power multiplication. Here multiplication, instead of that we are going to use addition. Here division, instead of that we are performing what? A constant value. Float that is division multiplication instead of that. So here multiplication. So where the exponential, that is power of 2 can be available, then we can replace with a small only one operation, that is multiplier. So this is a higher one, this is a lower one. So compared to this, we can use that, but the result is same, x over 2 which is equal to x star x. So instead of this one, we are going to use this as a multiplication in case of algebraic transformations. And 2.0 star x. So here this is a multiplication which is expensive. Instead of that, we can write x plus x. This will be easy. X divided by 2, which gives the same result. That means x divided by 2, that is equal to x into 1 by 2, that is x star 0.5. X star. Now the performer, that is a multiplication operation. This is multiplication operation. Now that is to be carried. So we are going to get rid of division with multiplication. So that is advantage of this eliminating the usage of strength additions. Here in this case, instead of writing x plus 0 or 0 plus x, simply we are performing x result. If we are performing subtraction, simply we can write x. Instead of performing multiplication, simply you can x. Instead of writing x divided by 1, that is x into 1 by 1. X into 1 by 1, that is x. So that is where you can perform the expensive operations can be cutted off with the lowest operations. Another example of this related optimization is constant folding. That means here the expression that is to be used applied. So in this example, so this is the example which is related to this class of optimization, that is constant folding. So where the expressions are to be evaluated with the combinations with several times with the same expression value. So instead of that, we can replace that constant or we can go for with the remainder. So for example, in this A equal to B plus C and E equal to C plus D star B, we are going to apply this intermediate code. What is this intermediate? A equal to B plus C and C plus D can be assigned with a new term T equal to C plus D and E equal to T plus D. So here, if we are going to observe B equal to C plus D plus B, which is same as B plus C plus D. But B plus C already it is computed. So we can write E equal to A plus D also. So instead of writing, so these two expressions, these two. So this is the expression which contains the computations how many, that is addition, 3 additions. This is a plus operator A equal to B plus C, one addition operation, and this in this case example C equal to C plus D plus B. So 2 addition operations. So total 3 addition operations. So that is to be get rid of with result which is same as these 2 statements. So this is 1 addition and this is also 1 addition. So like this, and this is a small example which you consider. So if you go for bigger ones, then where expression which involves lot many plus minus star division power exponential things are there, then definitely it leads to the optimization point of view and compilation point of view, very less lines of code and respect of time and cost. All these factors are to be effectively implemented, improved whenever we apply this type of coding techniques, that is optimization such as constant foldings. So in this case, we applied and we shot out with this one. So performing the removing the three address operands, that means B plus C. This is also eliminated. So recomputation. See here, A equal to B plus C we performed. Now in this case also B plus C plus D. Now once again B plus C we are performing. So that is recomputation several times. So now need to compute once again. So the result is to be kept A plus D. That is the result of the second expression. And also we can implement this one with a graph notation representation of the as a flow graph notations also. So till now we have seen some of the problems which are related to the transformations, that is algebraic transformations, and the code optimization, that is constant folding, this example, and previous example, that is strength reduction, that is basic blocks where several lines of code, and also there is this power expensive operations can be removed with the smaller operations, and loops, the statements which are available inside a block of statements can be verified with the computations, and if needed it can be placed outside of the block and can execute. Induction variable eliminations, code motion, where the presence of the code inside the loop, inside a while loop is not required, kept outside and make a temporary notation, and the repetition of code is to be avoided. And constant folding, where the assignments are to be calculated easily and kept that actual value as assignment statement instead of performing a division operation. And also copy propagation, which is used for dead code eliminations technique, where the code is not required for the execution purpose, and variable substitution of the variables, and also the recalculation of several computations with multiplication several times, and assignments with the T6 and T8. So we are going to verify that type of lines of code, and definitely it reduces the shorter lines of code, and the compilation point, it gives a very less amount of time taken place for taking these executions. So all these are all some of the problems which are related to this code optimization for performing the techniques. Another one is graph terminologies. In this example, we are using the computations, several computations, that is called as flow graph computations. So this flow graph computations, which is used for the entry node says DDOM, which describes this one as the dominator, that means dominating nodes through N. That means N, and here nodes in the flow graph represent several computations. Edges represents the flow of control. So here node 1 to node 10. There will be several computations. Node 1 will take place some computation, that is expression value, and another expression at node 2, node 3, node 4, node 5, node 6, node 7, node 8, node 9, node 10. But a dominator tree can be written from this flow graph. We are going to write this tree is a dominator tree, and what are the nodes that depends on 1? So that is 2 and 3. So that's why we have kept a transition between 2, 1, that is for 1 in between the nodes 2 and 3. So and what are that's why it is a dominating D-dom. That bit, which node is dominating with the corresponding node here. In this case, every path initial node of the flow graph goes to N through D. Through the dominator node, every path will go. So that's why here in this example, the T2 dominator node path goes to 1 here. 3, it is a 1. Whereas 4 dominator path is 3, so that's why. Here for 4, 5, for 5 dominator is 4, and for 6, 4, 7 also 4, and for 8, 7, for 9, 8, for 10, 8. So that's why here, if we observe, node 1 who is dominating, so here it is the node 1, before the 10 node, this is the start node, root node. From above this level, there is no other node, so that's why it is a dominating node. No other, and it dominates every other node below that one, so that's why it is an initial node. Whereas node 2 means it is also dominating itself, and here the path begins with 1 and 3. So here they dominating with 1, 3. Node 3 dominates all but 1, 2. So here node 3, what is node 3? Here dominates all but except 1, 2. And node 4 dominates all but except what is 1, 2, 3. That means here, in this example also see here, above that level, what is that 1, 2, 3. But remaining edges to be transitions are to be eliminated, only dominating nodes are to be created. That's why it is called as dominant recti. What is the links that depends on this one? Is it actually path going through that corresponding nodes or not? That is to be verified. So for 6 also, if you observe here, 6 depends 4 only. So dominant node here. For 5, 4. For 7, there is also 4, but it actually depends. That is for 7 to that from that 6 to 7. 6 to 7 there is a transition, and the 7 to 4 is also there. So that's why here, even though 6 is available already, that's why you can count for as 7, 6 and 7. So then for 7, the 8 and then 9. So dominant node 7 dominates 7, 8, 10. Node 8 dominates 8, 9, 10. Node 9, 10 dominates only. So here node 7, 7, 8, 9, 10. Node 8, 8, 9, 10. So like this we are going to verify the dominator of this corresponding nodes, and we are going to write a tree notation. From this we are going to eliminate the remaining. So here the range from 9 to 1, that is to be available, and also there is a net which belongs to the 8 to 3 and the 7 to 4, that is the 10 to 7. So this type of things that is to be removed, only the dominator corresponding nodes that is to be, which are linked actually to that processing node, that is to be counted and to be written as a flow graph notation. Then this flow graph notation is called a dominated tree flow graph for the given flow graph. So flow graph nodes are all the edges. So it is a contains a collection of nodes and edges, and all the nodes which is represent several computation, that is expressions, and the edges represents the flow of current. The first node that is to be required, that is usually called as the initial node, and the parent of each other node is the immediate dominator to be described in this one. And each node D dominates only when the descendants corresponding dependents in the tree. Okay, thank you. We'll take one more new problem solving technique, another concept. Thank you once again.
Like, share and subscribe. Hit the bell icon for more updates.